In the context of automotive product development, that is the process through which cars are developed for production, study of vehicles in motion is a critical aspect of automotive engineering design. So let's say if a new project is started for developing a new type of a car or new SUV, the study of vehicle dynamics and the implementation of design features for vehicle dynamics is a centerpiece of the product development process. Hence, vehicle dynamics is an important part of engineering design of vehicles. So, vehicle dynamics is the study of behavior of vehicle as a system which is under the action of forces. So, general dynamics is study of bodies in motion under the action of forces, and vehicle dynamics is a study of the behavior of the vehicle in motion under the action of forces. The key word over here is under the action of forces, because any body which is under the action of forces will undergo motion, and it will have acceleration, it will have velocity, and it will have a dynamic behavior. So this is what we study in vehicle dynamics, the dynamic behavior of the vehicle under the action of forces. Now, if we consider the vehicle as a system, it will have an input and it will give an output. And then there are feedback mechanisms, feedback loops, which allow us to alter the input based on the output. So this is a very simplified model of a vehicle. You have input forces which are acting on the vehicle, which basically give you an output, which is the behavior of the vehicle. Based on the behavior of the vehicle, there is a feedback which corrects the input and modifies the behavior of the vehicle as a system. It is a very general model-based definition of a vehicle. Now, in terms of inputs, these inputs can be internal or external disturbances. Now, what do we mean by internal or external disturbances? So when a vehicle is starting to accelerate, there is an internal force, internal torque which is being generated from the engine, and hence it will disturb the state of the rest of the vehicle. It will want the vehicle to move. It will create traction at the wheels, and the vehicle will start accelerating. So this is an internal disturbance. Now when the vehicle is taking a turn, there will be lateral forces which are acting at the wheel. These are external forces which are acting. Also, because of the self weight of the vehicle, there will be vertical reactions which will be acting on the vehicle, which is also because of the internal properties of the vehicle. Also, because when the vehicle is going at a speed, there will be aerodynamic drag resistance forces. So there will be many different types of forces which are acting on it, and also there will be moments which will be acting on it. All of these constitute the input, and that is basically affecting the behavior of the system, and that will create an output. Now these outputs will be in the form of behaviors, in the form of motions, in the form of accelerations, and they'll be multi-faceted in terms of their output, and then there will be certain feedbacks which will be given to the input to correct the input for modifying the output. So this is a general model of a vehicle dynamics system. This is just to give an overall view of the model-based definition of a vehicle as a system. Vehicle dynamics as a field is a very massive field of study which generally requires dedicated degree programs at the master's level, at the postgraduate level. So vehicle dynamics is a very massive field of study. There are subject matter experts who are only working in vehicle dynamics in engineering design, in product development. So this is just to give you an overview. We will go into the details as we go through the course. Next, an important concept to consider is the cause and effect. So anything which happens in the world, there is a cause and effect. Similarly, for behavior of a vehicle, which basically is what we want to modify. So the main aim of vehicle dynamics study is to modify the behavior of the vehicle in different situations. So understanding the causes and effects of the behavior of the vehicle becomes of prime importance. So cause and effect understanding is very important. For example, a force which is either external or internal is causing the car to accelerate, it is causing the car to move forward, or it is causing the car to move sideways, or it is causing the car to bounce, it is causing the car to roll. So the force which is causing it is the cause, and the effect, it can be different types of effects. There can be different types of effects on the car. It can be the longitudinal effect, that is acceleration and braking. It can be lateral effect, that is moving sideways, sliding, or it can be even bouncing and pitching or rolling of the car, so rotating of the car. So there can be different types of effects on the car depending on the type of force which is causing it, or a combination of forces or moments which are causing it. To get a very foundational understanding of how vehicle behavior, we should understand the driver vehicle driver relationship. Now we have the driver who is giving the input, and that input is in the form of steering inputs, throttle, acceleration, and then brake. These are the three major controls which the driver has, which he or she can basically control the behavior of the vehicle. The driver is giving the input, and then the occupants are basically occupants in the car. They do not control the input, only the driver controls, and based on the input, the vehicle will the behavior of the vehicle will be affected, and the behavior of the vehicle is also affected by the road or the terrain on which the vehicle is running on. And these road and vehicle on the terrain which the vehicle is running on will give forces and moments at the tire. There will be forces and moments which will be generated at the tire because of the road and terrain the vehicle is running on, and the vehicle will give a response which is nothing but the output, which is nothing but the behavior. The response will be in the form of motions, in the form of accelerations, in the form of vibrations. So there will be different types of responses, different types of motions will be there depending on the degrees of freedom of the vehicle. It can have pitching motion, rolling motion, diving motion, sideways motion. It can have different types of motions, responses, and different levels of accelerations. For example, if the vehicle goes over a bump, it will have a vertical acceleration. Or if the vehicle is going through a rough patch in a terrain and which is having very regular pattern, so it will undergo vibration. So all of these are basically constitute the response of the vehicle. And then certain responses of the vehicle are felt by the driver or felt by the system, and then modification of the input is done to modify the behavior of the. For example, if you're taking a turn and if you feel that you're losing traction or the vehicle is going out of control, then the driver or you who is the driver is correcting the steering input to correct the response of the vehicle. So this is a very this is basically the central theme of vehicle dynamics, the driver vehicle driver relationship, and based on this only vehicle dynamics study is generated. So the driver gives an input in the form of steering, throttle, brake. The vehicle also is in contact with the road. The forces and moments are generated at the tire, and because of the interaction with the road and the input of the driver, the vehicle will give a response, and based on the response the driver corrects the input or the system corrects the input if there is any automatic control system, for example ABS or traction control system. So these systems they detect the response of the vehicle and they control the functioning or the parameters of the system to change the response. So it can be from the driver, it can be from the system itself. Anyhow, the input is corrected and the vehicle response is modified. That's how vehicle dynamics is controlled.